Good day, my esteemed viewers, and welcome back again to another very insightful tutorial. And in this tutorial, I'm going to be taking you through step-by-step method on how you can achieve the proofs that you can see on your screen. So without further ado, so that I don't take much of your time, come along, let me show you quickly because it's quite easy and straightforward. Now we are required to prove that the square root of 2 is irrational. So the first thing I want to understand is, what does it mean for a number to be irrational? Generally, numbers can be categorized into two. Either it's a rational number, either it is rational, or it is a irrational number. Now, what are rational numbers and what are irrational? Because you need to understand what it means for a number to be rational before you can say, you want to attempt this kind of a problem. Now, rational numbers are generally numbers that can be expressed in a form of a ratio. For instance, 2 over 5. This is, a rational number, and if I simplify this, I'll have as 0.4. So even if it's 0.4, I have as my initial number. I can express this as fraction and eventually becomes a ratio. That's what we mean by being able to express it in form of a ratio. Another example is 3 over, let me say 3 over 5, which is the same thing as 0.6. So any number that you can express in form of ratio, they are referred to as a rational number. In contrast, a number is said to be rational if you cannot express it in form of ratio. For instance, numbers that, yes, most likely they are decimals, numbers that they have repetitive numbers, that you cannot actually truncate. I'm sure you have seen some, let's say some roots or some numbers that will have something like 1.1616161616, and the 16 will be indefinite. These kind of numbers cannot be expressed as fraction, which is also known as ratio. So we call them irrational number. So then how do we now get to prove that the square root of 2 is actually irrational? Now let me wipe my board and let's get started. The square root of 2 is irrational. In mathematics, there are several ways you can achieve a proof. One of the ways is you prove that the contrast is not true. And what I mean by that is, if you have to prove that root 2 is irrational, if there's any way you can prove that root 2 is not rational, then you'll be able to conclude that yes, it is rational. And here is what I mean. If you can start, we can say, let's assume that root 2 is rational. So assume that the square root of 2 is rational. So it implies that we can write it as root 2 equals to a over b. Our first assumption is that we assume that the square root of 2 is rational. Now, if we're able to prove that square root of 2 is not rational, then we can conclude that root 2 is actually irrational. So the first assumption is square root of 2 is rational. And the condition that you should take note of is the fact that b is not equals to 0. And not just that alone, a and b, they don't have a common factor. So we also assume that a and b does not have a common factor, because from the initial explanation, you observe that for a number to be irrational, number one, you cannot express them as ratio. You can express those numbers as ratio, which also means that most likely those numbers, they don't have, in fact, since you can't express them as ratio, so there's no common factor between the numerator and denominator, as the case may be. So we assume that the number is rational, so root 2 equals to a over b, and then b is not equals to 0. And also we also assume that a and b, they don't have a common divisor. So if we can prove that a and b has a common divisor, then that means that the contrary is the true, which means that root 2 is actually rational. So let's go ahead with this. So if root 2 is rational, we have root 2 equals to a over b. So that means if we square both sides, when you square both sides, we have 2 equals to a squared divided by b squared. And when we cross multiply, so we can say that a squared equals to 2b squared. Now there's something that you will observe here. Any number that can multiply by 2, that means that this number is even. For instance, even if b squared is odd, once you multiply by 2, automatically all of this becomes even. So if the right hand side is even, so we can say that a squared is also even. And you also agree with me that if a square is even, definitely a is even, for a square to be even. And I'll take example. For example, let's take a square equals to 4. Of course, 4 is an even number. Since 4 is even and a square is equals to 4, it implies that a equals to 2, which is also even. So that's the first thing. So now we know that a is even. So if a is even, then definitely we can say that, we can assume that a equals to, we can express a like this: a equals to 2k for all values of k being integer. A equals to 2k for all values of k being an integer. So if we assume that a equals to 2k, so we can now say that, from a square, we know that a square equals to 2b square. So if a is 2k, so we can say 2k raised to power 2 equals to 2b square. So we have 4k square equals to 2b square. So then if we divide both sides by 2, so we have b square equals to 2k square. So we can conclude that we know that since b square equals to k square, so all of this we can say this is even. And if the right hand side is even, it means that b square is even. And if b square is even, that means b also is even. And don't forget where we started from. We assume that a and b, they don't have a common term as divisor. But we've been able to prove that a is even number and b is also even number. So which means that if a and b, they are both even, that means that they actually contradict the assumption that we started with, that a and b does not have a common divisor. So since they are contradictory, that means that root 2 is not a rational number. So we can conclude that root 2, therefore root 2 is irrational. And that is it. So that's just it. It's quite easy and straightforward. So I believe it's self-explanatory. So if you have any problem with the solution, you can also leave a comment in the comment box and I'll be there to attend to your problem. Thank you very much. That'll be all for now. I'll see you in the next tutorial.